The PC, personal computer, like any computer, is an IT device with inputs and outputs. A piece of hardware that runs on software. Hardware is a set of physically tangible computing devices, computer circuits, equipment, etc. Software is a collection of programs, instructional data, and documentation that run a computer. Informatics deals with the acquisition, storage, processing and transmission of information. The content meaning of information signs and signal sequences, which contributes to the operation and decisions of the system that creates and consolidates it, is therefore novel. A computer treats all input data as novel. News is information in motion. Data is a form deprived of the meaning of information. A signal system is a thing that conveys the content of a communication. Element of the sign, word, letter, number, etc. The digital signal system is a well-distinguishable, discrete system of finite numbers of signals. There is no transition from one value to another, each signal has a numerical meaning. An analog signal system is a signal system in which some constantly changing physical, chemical, etc. effect carries signals that are not clearly distinguishable from each other. The basic element of a binary digital signal system is binary digit, bit, B, which contains data points, 0 and 1, false and true, on and off, etc. 8 bits are called one binary term, bytes, B. Bit and byte prefixes, kilo, K, mega, M, giga, G. Among them, the conversion is 1024. 1 bit equals 1024 bits, 1 bit equals 1024 bit, 1 bit equals 1024 bit. 1 kilobyte equals 1024 bytes, 8192 bits, 1 megabytes equals 1024 kilobytes, 8,388,608 bits, 1 byte equals 1024 megabytes, 8,589,934,592 bits. Computer science is the computer branch of informatics. The information content of a binary data is given by the number of binary signals that make it up. 1 bit contains two values, 0 and 1, 1 byte contains the 8th power of this, i.e. 256 values. So the number of items that can be stored in 1 byte has an information content of 256. Microcomputers, including PCs, operate according to the Neumann principle named after János Neumann of Hungarian origin. The main features of the structure are that the computer uses a fully electronic and binary signaling system, and that the internal, addressable, writable, and readable memory stores program instructions executed sequentially, in sequential order, and instructions in the same way. Data to be processed by the same computer so that the program can be operated and written at the same time with the same computer. Today's PCs are the successors to the IBM PC that appeared in the late 1970s and have the same technical structure. The main reason for the proliferation of IBM PCs is that they consist of different removable hardware units, and newer versions of them are, usually, compatible with older ones, that is, with the same physical and logical interface, operating on the same principle. Hardware devices can be divided into 5 groups: motherboard, processor, memory, mass storage devices and input-output, I/O peripherals. It acquires information with its input peripherals, stores it with its mass storage devices, processes it with its motherboard, processor, memory and peripherals, and transmits it with its output peripherals. All hardware devices are connected to the motherboard, enabling data transfer, communication. The processor controls the data transfer, executes the instructions. The memory stores running programs and data to be processed until the computer is turned off. Mass storage devices, drives, store programs and various data, even after they are turned off, so they are loaded into memory from here. Peripherals are input and output devices connected to the computer, and users or other machines communicate with the computer through them. The efficiency of a computer is determined, among other things, by the characteristics of these units. The basic software, the operating system, the near system programs and development environments, and then the applications are built on the hardware through the built-in software, the BIOS, basic input-output system. The operating system operates the hardware, strives for the optimal use of resources, maintains communication between different parts of the machine, implements the communication between the hardware and the programs, and serves the user. Near-system programs help the operating system work, manage or control hardware devices, and in development environments, programmers can create different programs with the given language. Applications entertain, inform, or help users with their work, that is, near user programs. This is how the PC and the person who uses it connect. The PC works with machine code instructions consisting of binary signals and also stores and processes the data handled by the instructions in the form of binary signals. An instruction can be a transfer instruction that transfers data between two parts of your computer, such as the processor and memory, or the processor and a peripheral. It can be a control instruction that affects program execution or machine operation, conditional or unconditional program point jump, subroutine call, jump back from subroutine, conditional loop execution, interrupt enable and disable, or stop, and can be an operation that performs arithmetic and logic, mathematical calculations and bitwise right and left shifts and rotations, bits of operands in shifts. Shifts to the right or left by one or more place values, inserts new bits of value 0, and truncates the dropped bits, rotates the dropped bits to the new bits after rotation. All instructions are performed with circuits that perform basic tasks and work with binary signals. If it receives voltage, 1. If it does not receive voltage, it is considered to be 0. You execute the transfer instructions by moving the bits from one storage location to another storage location. It executes control instructions by sending control signals. Operations are performed using logic circuits, a logic adder, or gate, a logic multiplier, and gate, and an inverting NOT circuit. All operations can be traced back to these three basic logical operations. The AND gate and the OR gate have two inputs, let A and B, and one output. The NOT circuit has one input and one output. Operation of the OR gate: if either one or the other or both has an input of 1, its output is 1, otherwise it is 0. Operation of the AND gate: the output is 0 in all cases, unless the input of both is 1. Operation of the NOT circuit: if its input is 0, its output is 1, if its input is 1, its output is 0. A bit that is not monitored by the computer, whatever its value, may not be 0. But every bit that the computer listens on, that is, contains some value, has a given meaning. The computer stores each number, whatever its base, in binary digits, bit by bit, that is, converts it to a binary number. Stores all numbers in the specified type, in the specified length, in reverse order. The binary number with the smallest place value is on the left. Digits that do not fit in the specified digit length will overflow, that is, fall behind. In this case, it stores an incorrect value. For example, the binary number 10,001,110,001 on an 8-digit length is 011100001. It distinguishes signed numbers from non-signed, only positive numbers by putting a signed bit in front of the least significant digit of the number. If the number is positive, the signed bit is 0, if it is negative, it is set to 1. Because binary digits cannot represent a decimal point, that separates a decimal point or other numbered numbers, the computer divides floating point numbers, signed fractions, into three components: a signed bit, a characteristic, and a mantissa. The signed bit indicates whether the number is positive or negative. The characteristic specifies how many place values the binary number must be shifted to the left to start with 0.1 binary number. More precisely, 128 must be added to this value. The mantissa is after 0.1 shows a number. To prevent data from being lost when the machine is turned off and for programs to access, interpret, and process, it stores it in hard structured directories, catalogs, in readable and readable files, data files, of various formats, names, and sizes, on the hard disk, and various en masse storage devices. Because one wants to interpret the data stored on a computer, several different numeric only, and alphanumeric, numeric and alphanumeric, code systems are used, in which binary characters are represented by characters, numbers or letters, punctuation, and other symbols. Depending on the particular code system, each character has a binary value. The most common decimal numerical coding system used in personal computers is BCD, binary coded decimal, in which the 10 decimal digits are binary numbers with 4 place values. The most common alphanumeric code system is ASCII, American Standard Code for Information Interchange, which stores data in 7 bits in the standard version and 8 bits in the extended version. It contains 256 characters, so an ASCII character is 1 byte long, which is enough for the given to represent ABC, punctuation, marks, numbers, and other special characters. The decimal number system cannot be applied effectively in computing because 10 is not a power of 2, the basis of the binary number system. Instead, a hexadecimal, 16, number system that is relatively easy to convert to the binary and decimal number system and works well with the ASCII code system is used. The digits 9 to 15 are replaced by the first 6 characters of the alphabet to be represented by a place value. So its digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. 16 is the fourth power of 2, and 16 times 16 equals 256, so each character in the ASCII code set containing 256 characters can be represented by 2 hexadecimal digits. The digital and analog signal system. The digital signal is on the left and the analog signal is on the right. Information flow in the PC. In a computer, the drives communicate with the motherboard, the processor, and the memory, which communicate with the input-output peripherals and the peripherals with the outside world. The relationship between hardware and software. At the bottom is the hardware, above is the operating system, between the two is the BIOS, above the operating system are the near-system applications and development environments, and at the top are the user programs. The ASCII code page. The ASCII code page contains 256 characters.